Guys, so today we're going to start with factoring. This is going to be one of the biggest things you really need before calculus really starts making sense, especially once we get into limits. A lot of people look at this with certain expressions and think they look ugly or complicated, but a lot of the time they look bad because you don't recognize how to factor them yet. Once you do, they get way easier. So the main idea behind factoring is really simple. Factoring is really reversing multiplication. And if you want to think of that as dividing, sure, but that's what I like to say. Instead of expanding parentheses, we're going to be taking an expression and breaking it apart into pieces that multiply together. So for example, let's say I give you x plus 2 and then, sorry, x plus 3. And I multiply it out. How we multiply this is get the first term, multiply it by the next term, and then multiply it by the second term. So that gives us x squared plus 3x. Then we multiply the second term by the first term, second term by the second term, which then gives us plus 2x and then plus 6. And then here we see that these can be added up together. So same thing, x squared plus what's that, 5x plus 6. Boom. So factoring is really just going backwards. So I'm basically starting with this and I want to go to this. That's what really factoring is at its core. We're taking something that's written out, breaking it into multiple pieces. Now, for calculus, there are really three main factoring methods that you really do need to know. The first one is the greatest common factor, the GCF. This one is always the first thing you should check first before you do anything fancy. Ask yourself, is there something every term has in common that I can pull out? For example, we are given 4x squared minus 8x. Both terms here have a 4 within it. Both terms have an x within it. So what we can try to do here is we start off with 4x because that's what we're trying to take out. Do parentheses. If you want to think about it, it's like dividing 4x, both sides. Take out the 4, x squared, take away x, you're basically just given x. Here, the x's cancel out. 8 over 4, that's just 2. So we're given x minus 2 because it's still negative. So that's it. And if I were to expand this out here real quick, it'll be 4x squared minus 8x. That's simple. That's factoring. And this is important because sometimes students try to do way more work than they actually need to when the answer is literally just pulling out what the term have in common. And the second method is factoring trinomials. And this is probably the one you're probably going to use the most. This is something where we're given x squared plus bx plus c. And what you want to do is try to find two numbers that multiply to give you the last number and add up to give you the middle number. So let's do an example so I can teach you how to do this. We're given x squared plus 7x plus 10. So what I just said was we need to find two numbers that multiply to give you the last number, so 10, and add up to give you the middle number, which is 7. So how I like to do this is I like to write every possible multiplication for 10. So we're given 1 10 and 2 5. So just off of looking at these, which of these add up to 7? So that'll just be 11, and then 2 and 5 is the only thing that works. So it's really simple after this. You're always going to do x plus or minus something. So for example, we're going to be adding 2 and then x plus or minus something, which is going to be that second term, that 5 plus 5. Boom. That's it. And if I was able to go ahead and multiply these two together, it should give us the exact same x squared plus 7x plus 10. X times x, x squared, x times 5, 5x, 2 times x, that's 2x, 2 times 5, that's 10. So we can go ahead and see that we can, sorry, x, we can go and see we can go ahead and add these up together. X squared plus 7x plus 10. Boom. Which is exactly what we found up here. Perfect. Now let's say I'm giving a negative. Let's say I'm given x squared minus 5x minus 6. Still kind of the same thing. Now, if both sides are positive, both numbers are positive. If the last term is negative, then one side will be positive and one will be negative. So let me show you how to do that. So kind of the same thing that I like to do. 1 and 6, 2 and 3. Both of these multiplied lead up to 6. So what's something I can do? Most people get tricked up here and they try to do 2 and 3, but while you can do negative 2 times 3, it does lead to negative 6. This does not quite add up to negative 5 because that's our new number now, negative 5. It's not plus 5. So kind of we have to look for something else. So we'll go ahead and look at this first one. 1 times negative 6 does lead us to negative 6. 1 plus negative 6 does lead us to negative 5. Perfect. So, same process here. We're given x plus or minus, in this instance, plus 1. Next one is x plus or minus the second term. This term is going to be minus 6. And that's it. Simple as that. And I'll go ahead and expand this, or I'll go ahead and multiply this for you. First term times the first term times the second term times the first term, and then second term times the second term. So this will look like x squared minus 6x, 1 times x, that's just x, 1 times negative 6, that's just negative 6. Go ahead and add these up together. We're given x squared minus 5x minus 6. Boom. The exact same thing we had up here. That's it. So again, same idea, multiply the last term, add up the middle term. Now the third method we're going to use is the difference of squares. This one becomes really, really, really important once we start getting to limits. But the pattern is here. We're given a squared plus b squared equals a minus b, a plus b. And I'll go ahead and show you how that looks like. That means if you see something like this, for example, x squared minus 9, we can go ahead and rewrite it as x squared minus 3 squared. That's the exact same thing. And once we're given that, we can go ahead and factor it into this. X minus 3, x plus 3, following the same equation up here. All right. Another example we can go ahead and do is x squared minus 16. Same thing. X squared minus 4 squared. 4 squared equals 16. So we go ahead and write out x minus 4 and then x plus 4. Don't forget about the negative. Because this is negative, we need a negative somewhere in here. I just decided to include it in the first term. Now let's go into a couple of examples. Let's say I give you x squared plus 9x plus 20. I need two numbers that multiply to 20 and add up to 9. So just like we did before. Boom. So based off of looking at this, it will look to be 4 and 5. Because 4 times 5 equals 20, and 4 plus 5 equals 9. So process is the same. Always have the x plus or minus the first term, which is going to be plus 4. Have the x plus or minus the second term, which is going to be plus 5. Boom. And I'll go ahead and multiply this for you guys. First term times first term times second term times first term, second term times second term. So I'll go ahead and go a little quicker this time. We're given x squared plus 5x plus 4x plus 20. Multiply this together, that's 9x squared plus 9x plus 20. Boom. That's it. Our exact same thing up here. All right, that was just a basic trinomial. We're going to go ahead and move on to something else. Let's say I give you 2x squared plus 10x. What do we do here? So right off the bat, I can kind of see we can use our GCF. All right, looks like we can pull out 2x from both sides, like the same thing. You can think of it as dividing 2x from both sides. We're going to go ahead and write 2x first, parentheses, 2's cancel out, x squared and the x cancel out, the x's cancel out on this side, and we're given 10 over 2, which is 5. So we're given x plus 5. That's it. And if I was able to multiply this, we'll be given 2x squared plus 10x. Exact same thing we got over here. That's it. And this is a good reminder that not every problem needs a huge complicated process. Sometimes the best move is just to pull out the greatest common factor and stop there. Now let's do an important example, because this is where factoring connects directly with calculus. Let's say I give you this expression. X squared minus 4 divided by x minus 2. At first glance, some people look at this and think it's ugly or they don't know what to do with it, but this is exactly why factoring matters. The top, x squared minus 4, is the difference of squares. So I can write it as x squared minus 2 squared, x minus 2, which then I can go ahead and rewrite using the same formula, which I will add up here. This will look like x minus 2, x plus 2. All of that divided by x minus 2. And I'm going to go ahead and stop right there because we can do something really cool with this once we get into limits. And that's kind of the thing that shows up constantly when you're trying to get into limits. If you don't know how to factor, you're stuck. But if you do know how to factor, the whole problem opens up immediately. So that's why this matters. Factoring is not just random algebra topics you learn and forget. It is one of the tools that you use to make calculus possible. So in the short version, here's what I want you to remember. First, always look for your greatest common factor. Second, if you have a trinomial, look for two numbers that multiply to the last term and add up to the middle term. Third, recognize difference of squares patterns because this one shows a lot. Once you get those down, you're going to be in much better position for limits and for the rest of calculus. In the next video, we're going to go ahead and go over fractions because that's a huge reason people struggle before calculus really even starts. If this video even helped you remotely, please hit subscribe, please like the video, and I'll see you